I'm going to give you an example of an impulse momentum problem. So impulse uses the letter J. Some sources will use the letter I, so just be aware of that. Impulse is typically calculated using the area under the force as a function of time graph. Okay, and those of you that have taken some calculus might recognize that that is an integral. So don't worry if that doesn't make any sense to you. And then the second symbol that we'll be using is P for momentum, and that is just by definition the mass of an object times its velocity. So impulse is an interaction of force exerted for a certain amount of time, and then we have momentum, which is a property of an object, mass of that object times the velocity of the object. And the connection between this interaction of an object with an outside world and its property, momentum, is called the impulse momentum theorem. And so the total impulse exerted on an object is equal to the change in momentum. And this is actually not new fundamental physics. This is actually a restatement of Newton's second law. So you might be wondering, why is it useful? It turns out that it's useful when we have a variable force. You can use it for fixed force situations, but it's particularly useful when there's a variable force. So if you have a graph of forces as a function of time and it's not a straight flat line, we can still deal with that. With Newton's second law in kinematics, we typically have to only deal with fixed force situations. But this allows us to deal with a variable force situation. So let's I'm going to invent a problem for you. So let's say that a person pushes a box across a frictionless floor, and they, instead of exerting a fixed force, they exert a variable force. So the mass of this box is 80 kilograms, and then we also know that the force that the person exerts in the horizontal direction, so it's F subscript x, is going to start at 0, and then they're going to increase it to a maximum of 250 newtons, and then they're going to ease up steadily down to 0. And the time interval over which they do so is 3 seconds, and the maximum force that they exert is 250 newtons. Okay, so I'm going to use impulse momentum to make a prediction as to how fast this box is going. Assume starting from rest after the person exerts this variable force on the box. So first thing I want to do is think about the left-hand side of this equation. What is the total impulse? Well, in the x direction, the only force that's being exerted, if assuming this is frictionless, is the force by the person. So there's really not going to be a summation, but keep in mind in some cases there will be a summation. So the impulse will just be the area of this triangle. Okay, so just got to do a little bit of geometry. So impulse will be 1/2 the base, which is 3 seconds, times the height, 250 newtons, and I get 375 Newton seconds. Okay, now you may be looking at that and thinking, well, the units don't work out because we have Newton seconds over here and then kilogram meters per second over here. But if you actually do throw in the definition of the Newton, you do get kilogram meters per second, would be an alternate statement of the units here. So conventionally, impulse has units of Newton seconds and momentum has units of kilogram meters per second, but those are fundamentally equivalent. Okay, so now let's work on the right-hand side. So I know that there's only one impulse, and I've calculated it. And so the change in momentum will be final minus initial. So it will be final momentum, which would be mass times final velocity in the x direction, minus initial momentum, which is mass times initial velocity in the x direction. Okay. And then I'm going to simplify this. I mentioned that this box starts from rest, so that goes, this part goes to 0, and then this is a very easy problem to solve. We're just going to solve for the predict what the velocity of the box is going to be after this person pushes it. So it would be the impulse, which is 375, divided by its mass, which is 90, and I end up with 4.2 meters per second. Okay, so a testable prediction as to how fast and what direction this box is going to be going after this person pushes it with this variable force. Okay, thanks for watching.